Hi, I'm Carl Loveridge from Extra Cheesy Games, and today I'd like to do a video tutorial on shader creation, in particular how I'm doing a sky dome. Now, one of the ways I'm going to do these shader tutorials is I'm going to assume you have some basic knowledge, and I'm looking at this from the perspective of I'm trying to teach more of the way to think about your problems and then look at your tools and figure out how you're going to use those tools to make some kind of a visual effect. So I'm going to just show you what we're going to talk about and how I created this, and then we're going to go over the shaders. In my game, Humans Must Eat, I have a backdrop behind the game as you're playing it. Now, I've accelerated the time on this. I'm going to let you watch it once, and then we're going to talk about how it's broken up. Now, what I want you to focus on here is see how the sky is changing color. And I've sped this game up so this plays over 10 seconds instead of a full day. And you'll notice a couple things. Stars appear, and the buildings down here went from a day version to a night version. Okay? And so what we're going to do is we're going to talk about this. Now, you may not like the visuals of what I'm doing here, and they're not finished. I think the stars are a little mushy. But I'm going to think of this. I want you to think about this the way Toby Flenderson looked at this in The Office. If you remember, there was a part where Toby had his computer searched in case he was the one that was the gateway that they're having problems with the printers, and Joe, the boss, pulls him in. He says, "Hey, I noticed you had a novel on your thing," and he starts talking about it. She starts talking about him. Finally, she suggests, "I think you should write it this way," and then they cut to Toby. He goes, "You can write your own damn novel." So if you don't like my visuals, you can write your own damn visuals. But I'm just going to show you today how I achieved this sky dome. Interesting enough, I found a bug because my game should not have paused like it is so you can see it so clearly. All right. Now let me give you the details of how my sky dome is put together. As the visual artist of all this, I want to show you my thought process. One thing that I think is interesting is I hit the button that makes my thing makes my video or changes my scenes in my Unity, but then all of a sudden the video stuff came up. I think we're still recording. Okay, so let me do it by hand. I have a game scene here. I'm going to show you my sky dome. The way I've done my sky dome is a little bit different than maybe you initially think when you look at it. I have a prefab that has the backdrop built into it, but you'll notice you don't see the backdrop. Then the bottom pieces, the daytime version and the nighttime version of the sky dome, or the cityscape behind that, are in as children of the sky mesh. So where's the mesh for the sky dome? Well, or for the background. What I've done is I've actually written a C# piece of code here where my sky goes through and is built programmatically. Now, I'm not going to talk a lot about that today, but I'm going to give you at least the philosophy of how this happens. Let me go over to also let me make sure this is big enough for the video, because I don't want to do the zoom effect. Where's this at? View. Zoom in. I don't want to trust that hotkey. All right. Let me first of all, let's talk theory about how the sky dome was made. And excuse the crudity of my backdrop here. Okay. So what I wanted to build was a sky dome that would go through time of day changes, right? So what I wanted to have behind it is a polygon that looks like this, that I use the vertex color to do colorization, right? It's nothing more than a gradient, right? So if I wanted to make a color like that was sky colored, I might have the top be one color, the bottom be another color, like this. So when it draws, I get that kind of an effect, right? Then what I wanted to do was to sandwich the sky content. Here, let's make this fancy, shall we? Where this guy, I'm going to merge this details down. Look at this. Using Photoshop on the fly, like I didn't intend it to. Merge, visible. So then this piece here, see, I'm getting caught up on this thing. Now it's just too fun to sit here and screw around with this thing. Edit, free transform. Just going to let me know if you don't want to do skew. Hey, you're getting a Photoshop tutorial for free. All right, so this piece here, what it was going to do is these things are going to merge together. And my camera is just going to sit here out at this area. I'm worried way too much about the details on this thing. The camera's out here looking into the scene. And also, I wanted to make the this version of it have a night version. So on my day version here and my night version, so you think I could just remember where things were. Let's merge these visible. You get the idea. I'm not going to do it. All right. So the night version would just sit on top of it, right? Like that. Tutorial, lesson, what not to do. Okay, so then these two would be blended across. Pretend this one's the dark one. Okay. This was the night one. Okay. And I'm going to crossfade between those. And as a last effect, what I wanted to do was to have a layer that was a star field that would appear on top of this thing, right? All right. So we're going to make that amazing drawing happen. So part of the process of making visual effects is thinking through how you're going to build this. Now, a couple of challenges you run into with building visuals is you've got only so much resource, okay? And this little sky, I didn't want to burn a huge amount of space with this map of the cityscape. So I felt like it was important to actually separate that out into its own. The other thing is, you'll notice I have this at the bottom, so I have all this dead space above the city that I can't afford to draw empty pixels in my game and expect performance to stay good. Not on mobile. So I knew this element had to be sandwiched in post, and plus I wanted to do a transition between the two. So I went ahead and I thought I'm going to use this as a sprite, and there's other issues in there. But the effect where I wanted to include the stars in the field of background color, I could put that inside of a single shader. And really the meat of this lesson I want to talk about is that shader. Okay, so let's talk about the shader work that's being done. And let's talk just briefly about the component as well. One thing that Unity does extremely well is it lets you build and connect tech together. You know, and I wrote my own engine. I remember writing shaders was a very difficult thing to get hooked up to code. Certainly not as easy as Unity does it with C#. And doing tech like, oh, I want to access uniforms and all that stuff. They've done an amazing job of exposing that stuff to your C# code. So I have two parts to my SkyDome. I have a C# program here called SkyBuilder, and then the other part of this is the shader. Let's talk briefly about SkyBuilder and how I'm running this. All right, now I did not make a prefab of the sky itself, okay? And the reason I didn't is I'm using Vertex Color to light the background. And if you were inside of, let's say, Maya, let me pull down Maya here for a second. Start a new scene. All right, so I'm going to build a polygon here. If you're not familiar with what vertex color is, I'd be surprised, but I'm gonna give the tutorial for those that may not know what it is. Vertex color is an old school way we used to light content. So in other words, I can go down here and type a color in, and you'll notice the whole thing turned color. Now I wrote that tool that I'm typing that command in here. But what vertex color lets you do is I can come in here and I could say RGB 010, actually 01, and now I can colorize at the points along here. Okay, so like maybe in a sky dome situation, I'd want to obviously pick colors. I'm just hitting these menus just right. That's important. So if I had a sky color here at the bottom, I could do it with this tool as well. Two problems with doing it as a polygon out of like your favorite modeling package. One, I don't know exactly how big this thing is going to be, and maybe I can get away with that by just simply making the polygon bigger. But the other issue was I need access to those vertices because I want to colorize those on the fly. Okay, so for part of my problem that I had to deal with was how am I going to colorize these pieces? So my solution was to just simply build a polygon. Inside of Unity, and this is another amazing thing I think about Unity, is I can actually build polygons on the fly, and in this case I'm just going to simply build the polygon to the dimensions of the screen, and I'll have a polygon that I can sit and tap the colors programmatically as I'm in there. So first step was to build the polygon. And so if you've ever built a polygon inside of Unity's by code, you'll know all this code, but let me give you a high level explanation of what's going on. When my function awakes, first thing I needed to do was, let's see, where am I at here? Nothing on the awake, but when the start occurs, I generate a brand new mesh. I get what's called the mesh filter, and I cache that off. I sign that into. I sign my mesh into the mesh filter. I'm sorry, but I do cache that off. I just do some housekeeping. I assigned it, then I gave it a name, so it was called something. First thing, now here's the magic where the polygon's built. I'm actually building a polygon by taking the sky width, which is calculated by, let's see, did I make that as my own parameter? I did. Actually, you know what? I could have programmatically figured this out, but what I did is I just visually knew where my screen is. I have to take into account that this game could be on an iPhone, which is maybe more narrow than an iPad. And so what I did is I said, I'm just going to make this polygon big enough so that I know it's going to cover my bases in case I'm on the thinner or thicker or wider polygon. Also, my camera in my game is fixed at a given location. So through a little bit of experimentation, I came up with these numbers where the width was 8 Unity units, which is 8 meters wide by 13 meters tall by 5, and I'm pushing it back, forward. I get my camera Z in and out confused, so I usually end up doing this a couple of times by changing my code. And I knew a fixed location where this polygon needed to be built. So at the end, I make the polygon through an array of vector 3s. I assign those into the mesh, and the indices are constant. They never change. So I was able to just build the polygon. If you're not familiar with the way polygons get built, let's go back to my wonderful Photoshop skills. Let's do another page here. Hey, you get to get another tutorial on how to do Photoshop. Okay, so the way the polygons get built is like this. You don't draw a quad. You draw them in triangles, right? So I have 2 triangles that sit like this. There's triangle 1, triangle 2. Okay? So if you look at my order, I'm building this face so that this is vertice 0, this is vertice 1, vertice 2, vertice 3. Okay? So that's, if you follow the dimension, see there's negative, and I'm building around the origin. So there's the negative, which is the lower left corner, lower right corner, upper right corner, upper left corner. So the way Unity builds out these polygons is you make an array of indices which tells Unity how to assemble the polygons. So 0, 2, 1, 0, 3, 2, if you follow those numbers, 0, 2, let's see, let me look at the numbers. 0, 2, 1, so I tell it to draw it this way from this point at 0 to 2 to 1. And what we're doing is we're building this clockwise. If you build it counterclockwise, you'll inverse the face so it's backward, right? So 0, 2, 1, and then the second one was 0, 3, 2, so 0, 3, 2, okay? I don't know what that tick mark meant, but you get the idea. All right. So that's the indices. And you know, you can build any number of indices. I don't know, I'm certain there's a limit on mobile, but you can build them out and you can make a much more complicated thing if you want. I'll do a whole tutorial on building polygons in here. There are other ones out there which are pretty good. Oops, jumped over the shader. Okay, and the last thing is the UVs. And if you're not familiar with UVs, I'm just going to give you a high-level explanation. Basically, every polygon every vertice needs to know how it's going to map to the map. So this down here would be a UV address of 0, 0, 1, 0, 1, 1, and 0, 1. Is that right? 0, 1, 1, 1. Yes. And if you're not familiar with that, what I mean by that, if I build this polygon and I went into Maya, same principle. This lower left corner, 0, 0, 1, 0, 1, 1, and 0, 1. Now you might ask yourself, well, why is this a quad and you're having to draw triangles? Well, a lot of things get covered up in your tools just to make it simple. In reality, even if it's a quad or even an n-gon inside of Maya, you will, when it gets exported, it'll be converted into triangles. It may cut them up differently than you might assume it's going to, but it is going to be triangles. Okay, so at the end of the day, when we're all finished, I wrote a function down here that says update sky color, do it. Now, the one thing is, to construct a polygon on the fly every frame would be pretty expensive. I don't want to spend a lot of cycles doing that. So I wrote a function in here that just will basically evaluate the color. Now, the way I'm evaluating my color is inside of Unity, you can define variables, and I have a gradient array called my top tint and my bottom tint. Now, I'm going to tweak this just for a second here, just so this is clear. I'm going to change this to white, this to white here. So I'll explain what the alpha is doing in a minute. So now you can see what is the top vertice color going to look like, and what's the bottom vertice. And the reason I'm using a ramp is because it's changing over time, right? So what'll happen is as we progress in time, I normalize time so that at 0 I'm at the left end of the spectrum, and at 1 I'm at the extreme end of the spectrum. So as we're marching forward in time, I'm going to get new color information. So the way you evaluate color is I say type my top tint and evaluate at a normalized time of day, which if you go follow my current time of day, I'm taking and clamping the time, my update timer divided by how long does a shift last, and I make sure that in case the timer goes over that I'm clamping from 0 to 1 because that's what I need to get. I get my top color and my bottom color, and this color array is going to be fed into the mesh. Now, one thing about this is you want to use colors 32, which does convert these back into the 0 to 255 range. The way I'm going to give you some technical information here about how polygons are stored internally. Now, I can't warrant this exactly how this is done under the hood inside of Unity, but I know how it is down in the OpenGL hardware. And because I've written my own engine, I've had to deal with these things. In the hardware, let me give you just the high level what happens on here. You have, typically, it constructs a polygon as an array of content. Like, so let's say you have XY, an XYZ location, and usually this last one is also packed in there for the sake of keeping this simple. These are floats, and each one of these costs 4 bytes each. Then for my UVs, I have a U and a V. This is a float. Let's see. When I say XYZ, it's 4 bytes per channel, so it's 4 bytes times 4 elements because there's an X, Y, Z, and W. So you're costing yourself 16 bytes. For UVs, it's a float 2. I'm going to change this to a float 4 just so it's like that. All right, that makes sense. Float 2 times 2. So this equals 8 bytes. And then for color, see, if you use, this is why the number space on color is kind of critical. If I used a float number, so there would be an RGBA as a float 4, this would equal, color would equal 16 bytes. That's too expensive, okay? If I can zoom that up. I'm sure there is a way. Let's see if I can get that a little closer. You'd think I'd test these things before I show them. What kind of idiot does that? So what they do instead for color is we actually use RGBA as a byte each, right? Which equals now 4 bytes. So now I've made the cost of my color quite a bit less. So what happens is at the end of the day, each vertice costs this many bytes, which is 16 plus 4, 28 bytes. 28 bytes of data times each vertice. This isn't critical for small stuff, but obviously the bigger your stuff is, there's more content. And you know, if you start doing normals and you start doing a tangent and do all those things get packed. So by using this color 32, I think ultimately Unity would boil this down to a number space of 0 to 255. But if you use just a pure color, you're actually going to it's going to have to do a little bit of translation, so you're going to cost a little more time for it to have to go through that process of converting your floating point numbers down to those 8-bit numbers. Anyway, so what happens is this gets cut and put in here. I reapply that to the mesh, and the next time I believe Unity would reevaluate this thing. Now I get a different color. But see, I do not want this color change to occur every frame. I want this to occur only after so much of a delay. So what I did was I exposed what actually did the work as its own separate call so I could set it up the first time the game plays. But from then on, I start a coroutine which will basically update it every, let's see, what did I do it as? Start. I think I have this on start shift. I actually use signals and slot. I use signals to tell me when this shift starts. When the shift starts, I come down in here and I set my update timer to a given number. Let's see, this is telling me how much time has advanced, so that I can keep track of how much time has gone forward. So when I calculate my time, it's in there. But I started this coroutine right here that says updates my sky color. And this sky color, what I did is I cached off the weight somewhere in here, and in here there's going to be a yield on update. The yield on update, I've set it so every quarter of a second this gets done. Now you might ask, well, why did I put this up here? Well, I just know I've got to do lots of these wait for seconds. If I'm in a situation where I know I can use the same number rather than saying new wait for seconds every frame, instead I just did one and I just cached it off at the beginning and I recycle that bugger. That way it doesn't waste time and cause fragmentation in the memory. Okay. So I wait, and then when it's time to evaluate, I ask if, let's see, time is greater than night begins. Night has been activated. Okay, so what happens is in the beginning you're in the day, but once you start to hit a certain threshold of time, which I've defined up in my header of all this stuff, I start to implement the changing of the city from the day version to the night version. All I'm doing there is I'm feeding into the shader color that'll do a transition, and I'm actually using this with Dew Tween because I think once it got fired off, it's just a constant rate that it occurs. But the timing is based off of how it calculates how much time this has been set up. So the transition time here is calculated right here. There's another great tool I'm going to be an advocate for, is using what's called Dew Tween. It's by Demi Giant. There's a free version of it. I bought the professional version, but the free version is great. The professional version wasn't that expensive. It was like $10 or $15. I can't remember. It wasn't that much money. So anyway, at one point, once I realized that the SkyDome is completed the transition, I shut off the day version, because if you're drawing the two versions, you're paying the cost. So once the transitions occurred, I kill the day version. It gets shut off. At the end, I restart the coroutine again, because this is just going to keep updating. One of the things I'm fairly certain this is important. When the shift ends, I stop this coroutine so that I'm not doing that call out. Okay. That's how I did the transition on the sky. But let's focus a little bit now on the shader. Let's go look at my shader, and I'm going to post the code for the shader on there. Let me get my bearing what I want to show you next on here. All right, so you see how I explained how the polygon got built. I explained how the cityscape is generated and how I transition between the two. Let's talk about the sky. Now, what I did was with the sky, on my tint, you notice these alphas in here. What I do is this alpha is going to be purposed to make the opacity of the stars come through. So at the beginning, I don't want the stars to see the stars. So I'm going to shut them off in here, and they're going to be off until I start to get to be nighttime. Then I go ahead and I'm going to phase those in over time. And what I probably should do is move this in so they're in fully opaque. So this is going to transition the stars in through this. Okay. Back in Unity land, as I'm updating the sky, let's see. Remember, when I'm updating the sky in here, one of the things that, remember, if you look over here, this is the top tint. So I'm using the top tint. When I pull the color, the alpha channel of top will contain that opacity. So I go and I first of all make sure did I get my renderer for the backdrop. If I didn't get it, none of this would happen. But then all I'm doing is I'm feeding into my shader, which I called star opacity, how opaque it is, which is the color that came from the top color, right? So all I'm doing is feeding that in there. So let's go look at the shader. Let's go and find the shader here. Okay. So the shader, how I knew this got assigned in here, just so you know, when you make your own polygon, you still have to do it as though you imported it into Unity. I made a material called Vertex Sky Matte. If I click on this guy, there I'm pointing to my Sky Vertex shader, and all the shader exposes for parameters is a texture for my SkyDome and this star opacity and what color I want my stars to be. So I can tint my stars. Now, if I want to get fancier and I said, well, maybe stars need to be more colorful, I'm going to have to do a little more work to this. I probably wouldn't use the map quite the way I do, but I'm going to show you how this is set up. So those are the parameters that have been exposed in the Vertex shader. There they are again. The color for the stars or the star field, the color, star color, opacity. There is the properties that are exposed. This is just a very simple fragment program, a Vertex fragment program. I'm figuring out my matrix here. So the vertices put in. I also take my UVs that got fed in, and my color. That's what's happening in the Vertex program. Let's go to the fragment here. Here I'm reading in my stars, and this is what my star map looked like. All right, let's go into. I never opened it in here, so let's go grab it. Yeah. Now, I'm not normally an advocate for using non-square maps, but being that this Sky Dome is generally going to be on a map that's roughly this shape, I'm going to use this. Plus, I don't care about MIPPing. You can't MIP a non-square map. So it works in my case that this is just going to be a non-square, but it is still power 2. I may have to make this bigger than it is. Currently, it is a 256 by 512. Stars are a little soft in here. It's always a big debate. For something this simple, I hate burning huge amounts of texture for it, but I may end up biting the bullet for this. But anyway, that's the map. All I care about that it's grayscale, right? So I don't even care about color. This may be where I change the shader a little bit. If I want colorized stars, I may end up actually making the color changes inside of here. But for now, it's just a grayscale. All right, so I read my star, and I'm timesing this by the star opacity. So if the stars are pure black, if I set the opacity clear to the extreme end, you won't see stars because I'm multiplying that black or that color against the star field, which would clamp everything back into black, right? So the first factor I do is I convert that to black. The next thing is I'm going to colorize the stars. So I take the star information and I colorize it through whatever your star color is. And because most of this is black, it works that all the white specks of light get colorized. The last thing is this, or the next phase is this is the color from the vertex information. I should just name that vertex color. Here, I'm doing stupid things here. Let's call it vertex color. Is this, and I think I have to just make sure I don't mess that up. So there's the vertex color. Now this is where it starts, the magic occurs. What I did is if you multiply a color against a black against any of the colors, you get black. So what I did is I wanted to knock out the stars in the vertex color, right? So I invert my star map. If I didn't do this inversion, the stars would not be colorized, but the blackness would have been. Actually, it would have made my Sky Dome black. So I invert it right here, and then I just add the star color back in. So now the stars just get poked in. So think of this command here as this vertex color times 1 minus stars as knocking out where the stars are going to be. And then I add the color in here, and at the end of the day, I just pass the color back out, and the opacity is 1. This doesn't matter because this is not a alpha shader anyway. You just have to do that because I have to return a half 4. Okay. So that's it. That's the basics of the Sky Dome. At the end of the day, it gets built. So I'm going to post the shader so that you can see it. Let me make sure I didn't damage it. One thing about shaders, if you make a mistake with them, it'll air out, and it's really easy to do something stupid like, oh. In fact, yeah, if I misname something, it won't work. Let's see if I, by chance, damaged any of this. Doesn't look like I did. I usually get an error right up front. Let's go and play. Make sure it's still running. Yeah, so I can tell it's running because the Sky Dome isn't gone pink. So that's it. That's how I did the time of day and how I'm doing my backdrop. Eventually, I'm going to have things like maybe you'll see your advertising balloon behind the buildings, and it'll kind of float around, and they'll put clouds in here. All that good stuff will come as I make this. Let's see if our night time of day is kicked in properly. Yep, there it comes in. And it is mushy. I'm going to have to tighten that up a little bit, but you get the idea. So that's how I do my time of day Sky Dome, and I appreciate you watching. If you have any questions, please post the comments. If I'm not making something clear, I would love to hear what I'm not explaining. I don't know when I think about who my target audience is with this. I'm a visual effects guy at work, and so I'm going to assume that you have done some of this. And just in my last little bit of this, I worked with the same company for about 15 years, and we always did it the same. And I remember thinking, I thought I knew a lot. And then we started with Zynga, and we got a chance to look at some content in a game called Harvest Swap. And I saw how another team assembled their content. And I got to tell you, a bunch of things went off in my brain going, I never thought of that. That's a great idea. That's a good idea. So I think it helps to have some diversity in where you're learning this stuff from. So my hope is, as a visual effects artist, that you will see this and go, hey, that gives me some ideas how I can solve some of my problems. That's more of my goal with these things than to go through the nuts and bolts to extreme level to explain how a shader is assembled. And I'm going to do this through other shaders as I go. But I appreciate you watching, and hopefully if this is useful, give me a thumbs up on this. And if you want to see anything in particular, let me know, and I'd be happy to consider how I could put it together for you. I'll post the shader code. I won't post the Skydome code. It's so specialized it may not make sense. But that's it. So thanks for watching, and keep on gaming.